Okay, so we're going to talk about energy, and in specifically in these lessons, energy of objects in motion. Okay, and that means kinetic energy and potential energy, energy transfer, types of energy, and so let's get started with it. Mr. Hughes. Okay, Mr. Hughes is going to have to. Oh, here, I can fix it right there. Woo! I hate when I put the transparent background instead of full screen. Okay, so everybody there? Okay, so we're going to talk today about energy and its forms. Now, you have a copy, and this is for you at home. You have your copy called Energy of Objects in Motion. And you're going to follow along with me. You should have opened it up in Kami. And to the left there, to the left of the document, you'll see several icons there. Some of them are text, some are erasers, some are markers, some are drawing tools. And so that's what Kami is all about. In your document, you're going to answer questions as we go. And I'll let you know when we're going to answer the questions, okay? Or ask when we're going to answer questions, and you'll see it here. Okay, so stay with me. Okay, so you're going to scroll to energy and its forms, and we're going to get started. Okay, so our first question is, because we're talking about energy, right? So what is energy? Well, energy, you don't have to write this down. Just note that you got it there. Energy is a measurement of an object's ability to do work. That's all energy is. It's the measurement of an object's ability to do work. So how do you define work? Well, how would you know if work was being done? Does it look like work's being done here? These guys look like they're working. They look like they're working for me too. Actually, I've actually used these tools like this before. Before I became a teacher, I did concrete work, and I also did bricklaying work for a while. Brick and block, like these blocks on the wall here. I did that kind of work for quite a while. So I know about work. And let me tell you though, this is just as hard or harder. It's just as hard to teach as it was to do this kind of work right here. This kind of work you get physically tired. This kind of work here you get physically tired. The kind of work that I'm doing now, you get not only physically tired, but you get mentally tired too. Kind of like you. You guys get mentally tired, don't you? Come to school, listen to teachers talk to you all day, it kind of, woo, it wears you out, right? At the end of the day, you're ready to relax. Okay, so, so essentially energy is a measure of an object's ability to do work. So we have to define work. And we're going to define work, but we're going to define energy first. So again, energy is a measure of an object's ability to do work. So, and work, listen, work is defined as applying a force in order to move an object in a given direction. Let me show you some work. Oh, Mr. Hughes is pulling this cart here. Am I working? Yes. Am I applying a force in order to move an object in a given direction? Which direction am I moving it toward? This way. I'm pulling it, right? Okay, how about this right here? I'm pushing this object now. Am I doing work? Okay, so I'm doing work here, right? So work is defined as applying a force in order to move an object in a given direction. So when work is done, when a work is done on an object by another object, there's a transfer of energy between objects, right? So, and since energy is equal to work, the unit for both is the same, okay? And it's the joule. And joule, J-O-U-L-E, and you'll see it in a math problem as J, or sometimes you'll see it 1 joule equals a Newton meter. Remember, you guys remember Isaac Newton? Did we talk about Isaac Newton before in here? Okay, so a joule, so energy is measured in a joule. Okay, so work can only be done to a system by an external force. Okay, what does this thing do? What are these for?
To pull heavy stuff.
They pull heavy stuff, and specifically, they pull airplanes around around the terminals, right? Like if they're gonna service them or whatever, they'll pull them, or sometimes they back them up into this terminal part. These people walk from the airport in to get into the plane through these little, like metal containers.
Yep.
So let's say our system is a plane. The gate assistance vehicle, that's what this thing is called here. Look at the size of it compared to the airplane. That's pretty small, isn't it? So anyway, the gate assistance vehicle is not part of the system. When the vehicle comes along and pushes back the plane, it increases the energy of the plane. So the assistance truck is an outside force doing work on the plane. Make sense? Okay, so here's work. This is how you define what kind of work you have here. The amount of work done is the change in the amount of energy that the system will experience. And this is given by the equation work equals, you take your E final, energy final, subtract the energy that you started with initial, and that's going to give you the amount of work that you did. Okay, so let's look at these. Let's look at this right here. Okay. Okay, so let's look right here. When a force is applied to an object that causes it to speed up and move a distance, the work is what? When a force is applied to an object that causes it to speed up, the work is what? Positive or negative? If it speeds up, positive or negative? Positive. I like the way you said that, Andrea. Positive. Can anybody guess the other one? Anybody want to guess the other one?
Negative.
Okay, this is positive. And how about this right here? When a resistance force, when a resistive force is applied to an object that causes it to slow down, is that positive work or is that negative work? Negative. Okay, you guys are sharp. You got that down, don't you? So you have the concept down, right? If it speeds up, it's positive work. If it slows down, it's negative work. How about if it doesn't do anything at all? Look right here. Let me show you something here. You guys know how heavy this thing is, right? Woo, Mr. Hughes. What? Let's see if Mr. Hughes can move this thing here. Whoo! Did it move? Did I do any work? No, I did no work. Now, I'm tired. I could do this all day and I'd get really tired. But you know what I did? I just wasted my energy because I didn't do any work. That was literally wasted energy. And that's kind of the way it is in here sometimes when you're talking and I say, hush! You're wasting energy. Okay? Okay, so remember this formula right here. We're going to use it later. You can do it with a calculator, by hand, doesn't matter. And so it's easy. Work equals, you take your final amount, subtract the initial amount that you started with, and that's your work, okay? Okay, so look here what these kids are doing here. If an object moves in the same direction as the direction of the force applied to it, the energy of the system is increased. So work is positive. So work has to be more than zero, right? Are these kids doing any work right here? What are they doing? They're pushing the vehicle. Is it going in the direction that they're pushing? Yes, so that's positive work, right? Okay, so they're doing positive work. Okay. How about this right here? If an object moves in the direction opposite to the direction of the force applied to it, then the work is less than so work is less than zero, and the energy of the system is reduced. Look here, the parachute moves down, right? While the air resistance is moving upward on the parachute, so that's negative work. This guy's in a World War II uniform. Anybody's parents in the military? Do your parents have the new uniforms yet? Because they look kind of like these right here this guy's wearing. green, kind of green tops and brownish looking pants. Okay. Okay, so, uh-oh. Woo, what kind of work was I doing here? It wasn't negative work, it wasn't positive work, it was, look at these guys, they're on this, it was zero kind of work, that's what it was, I was wasting energy. These people, this is cement panels, looks like. Woo, you think they're doing any work? No. Okay, so if an object does not move, even when there's a force applied to it, like this right here, that makes my leg jump up and down for some reason. So if an object does not move, even when there's a force applied to it, then no work is done on the object. So work equals 0 joules. That's the J for joules, right? So the people exerted force onto the wall, but the wall does not move, so they're just wasting their energy, aren't they? So how many kinds of work do we have? 3. Can you name one of them, Andrea? Tell me, help her out, Isaiah.
0 work.
0 work? What's another kind of work, DJ? What's another kind of work? 0 work, what's the other kind of work we just talked about? Positive work? This is positive work, right? Because I'm moving this object. Okay, how about, what's another kind of work? Tell me. Negative work. A perfect example of negative work. Look here, you're trying to push a truck up the hill. You're trying to push anything, a bicycle, anything, up a hill, but it keeps coming back this way. Is that positive work or negative work?
Negative.
Ooh, you better get out of the way too at a certain point, right? Because you get run over.
Yeah.
Okay. Okay, so let's look at, we'll look a little bit at mechanical versus non-mechanical energy. Okay? Okay, so energy exists in many forms, but can be broken down into 2 major kinds of energy, okay? And mechanical energy, and that's the energy of an object due to its motion and position, okay? Mechanical energy is usually used to describe a large object, and it's the sum of the kinetic and potential energy. And we're going to talk about, we talked last year about kinetic and potential energy in here, I know we did. And we're going to talk more about it. So mechanical energy is the sum of kinetic and potential energy. And then you have something called non-mechanical energy, and think electricity. You have to have a tool or something to get electricity? No, it's like there, right? And in chemical energy, like in your battery of a car. Thermal energy, that's like your stove. And then you have sound energy. That'd be like if somebody were to pull up outside here and they took their band instruments and set up here on the ground. They started playing. Could we hear the sound? Yeah. And do we hear the sound of the lawnmowers when they were mowing out here?
Yes.
Woo, it's terrible, isn't it? Okay. And all that sound is coming directly through that black wall right there. Okay, so it's sound. So these are different kinds of energy here, okay? So non-mechanical energy is the energy of an object that's not due to its motion or position. It usually describes an object at its atomic level. Okay, so let's ask a question here. Oh my, I hope you didn't miss it. I hope you did not. There's 2 answers here. 2 answers to this. Which of the following is the unit for energy? Actually, there's only one answer. I'm sorry. There's only one answer. One correct answer. What is it? Is it meter or joule? Meter or joule? The unit for energy, is it meter or joule? A or D? Mark your answer. That's in the document you have there in CAMI, right? Everybody know how to do that? You know how to do that? You've never done this before, have you, Calvin? Let me show you how to do this here. You got this open and, yeah, good, okay, so here's your choice here, dude, you can either take, there's a drawing tool. That's a drawing tool, yeah. Take the drawing tool, or there's a highlighter here, I think. You can do shape if you want to circle it. Oh, here's a markup, so you can do,
You circle it?
you could, if you want to do shapes.
Yeah, probably just do shapes and just circle it.
Okay, so you move it over, move whichever one you think the answer is, either A or D, mark your answer. What do we say the unit for energy is? Is it meter or is it joule? Mark it, don't blurt out an answer, just mark your answer. Okay, I'm gonna move on now, everybody got an answer? Okay, be sure you mark your answer. I'm gonna take a grade on these. Okay, so think about this, we just talked about this. Listen, a wagon's rolling down a hill. A man tries to stop the wagon. Here comes the wagon. Woo, it's rolling down the hill. But he's unsuccessful. Is he doing positive or negative work?
Negative.
Don't blurt out an answer, mark your answer. A or B, mark your answer. You can highlight it, you can circle it, put an X beside it, doesn't matter to me. As long as I can tell that you chose one answer. Okay? Everybody got an answer? I'm moving on here. Okay, so look here, a boy kicks a soccer ball into a net. Kicks the soccer ball into the net. Is he doing positive or negative work on the ball? A or B, that should be an easy. You guys all should make 100s on this one here. This is easy. Everybody got an answer? Anybody need more time? Okay. Woo, look here. Oh, think about this for a second here now. Look here. A woman walks across an icy sidewalk that has been covered in salt. Now think about what happens when you walk on an icy sidewalk and it's covered in salt. Is the salt, now think about the salt. Is the salt doing positive energy or is the salt doing negative work? Is the salt doing positive or negative work on the woman's shoe? The salt. Think about what the salt does. She's walking on icy sidewalk, but there's salt underneath her on that ice. What is the salt doing positive or negative work on the shoe? Is it going against or is it going with the shoe? If it's going against, that's negative. If it's going with, it's positive, right? Okay, so that might help you answer that question. Okay, I'm gonna move on now. Everybody got an answer? Okay, so look here. Jill is waiting for the bus, and she forgets her mittens. So she rubs her hands together. Rub your hands together. Woo, what happens when you rub your hands together, even on a cold day? Ooh, yeah, they can get really hot, actually. So she rubs her hands together to keep them warm. In this situation, there is what kind of energy due to the movement of her hands? What kind of energy is that? Remember we talked about the different kinds of energy? Let's look and see what energy you think that would be. You can scroll back here. Look here. I'll give you a choice. Would that be thermal energy or chemical energy?
Chemical.
Mark your answers. Chemical or thermal? Mark your answer. Chemical or thermal? Think about that before you answer that question. Okay, so look. I'm sorry. Look here. Here's your choices here. My bad. That is thermal energy, but what is thermal energy mechanical energy or non-mechanical? Is thermal energy mechanical or non-mechanical? Don't blurt out an answer. Just I want you to look here. Did we say that It is thermal energy. Is thermal energy non-mechanical or mechanical? Okay, that's how we're gonna answer that question. I looked at the question wrong, I'm sorry. Okay, so look right here. So it's either gonna be mechanical and non-mechanical, or it's non-mechanical and mechanical. There's also a blank energy due to the heat she generates by rubbing her hands together. Is that mechanical energy? Are you moving something? Okay, so mark your answer, A or B. One of those is non-mechanical and one of those is mechanical. Okay. Everybody got an answer? You're just gonna mark A or B. Okay, so, and we're gonna stop right there, actually, we're gonna stop right there. We are going to stop right there. But now, I'm gonna stop the video.